Hello, this is Shiyu from MEMS 5001, and my project this time is optimization of automatic parking strategy. My bachelor degree is automotive engineering, so this time I want to do something about vehicle. Cars nowadays are no longer absolute mechanical system. They are usually a combination of mechanical and electrical system, controlled by computers, which is also called intelligent car. Intelligent car is an important development direction for vehicle industry. Among many advanced techniques for intelligent car, automatic parking is a challenging and practical one. Automatic parking system can obtain the position information of the car by all kinds of sensors, and then park the car by controlling the steering angle of front wheel and velocity. The picture here shows the main common steps of vertical reverse parking, and we usually start from position 1, which is perpendicular to our parking lot, and we usually turn our wheel to the left, and we move forward to position 2, and we turn our wheels to the right, and we move backward until our car is parallel to the parking lot, and then we keep moving backward straightly. This is also the main situation my project is going to talk about. Detailed parameters of cars and parking lot will be given in the future work. I have two objectives. The first is to find the feasible start position. The automatic parking system can only operate in feasible region. It cannot work wherever you want. For example, if your car is very much far away from the parking place. The next is to find the best parking route. The car should be close to the center of the parking place, and the length of the route should be as short as possible. In other words, we want to make parking safer and quicker. Then, why is it important? First, cars getting more and more, which leads to lack of the parking place. New drivers are facing parking problems every day, especially in big cities. Then the optimization will give us the best parking strategy, which is both safe and quick. We don't want it to take half an hour for a car to do parking and then crash happens. The optimization will save drivers time and money and make the parking easier to operate. The last, quantitative calculation will provide more theoretical basis for development of automatic parking. About my plan? Well, first I'm going to build a XY coordinate system to transfer this problem to a 2D math problems. Then I will use the core idea of this project, which is Ackermann steering geometry. This geometry tells the geometric relation between when the car is turning. I'll combine this Ackermann steering geometry with constraints of the parking space, and then we can get feasible region. Next, according to the safe driving area of the start position and the rationality of the final position, we can get many constraints. We set the length of the route as our first objective and the deviation distance as the second. The deviation distance here is the distance between the center line of the parking lot and the center line of the car. Then we will have a nonlinear constraint programming. The final step is to solve it, and I will probably use MATLAB or genetic algorithm, or maybe both. I'm not sure right now. Last, I want to talk something a little bit more about Ackermann steering geometry. As you can see, these are the four wheels of the car. This is the anterior axle, this is the posterior axle, and this is a triple zodiac steering mechanism. According to Ackermann steering geometry, when a car is turning, the four wheels will have different route, which is shown as here. But they will have the same center of turning circle, which is shown here. The Ackermann steering geometry also tells us the relation between the steering angle, which is shown as here, and the radius of the route of each wheel. I'll talk in detail about this geometry in my report and future work. So, in conclusion, This project is focused on a reverse parking problem. First, we build a multiple objective geometric optimization model and solve the problem by optimization method. Finally, we can get many ideal start positions and the best route associated with them. And that's all about my project. Thank you.